So, for example, if you needed your raster to represent individual cars in a parking lot, let's see what would happen. So at a 0.5 meter resolution, this little section of the parking lot, and you can see that we have buildings here, and then we have a parking lot. This is just outside Simard Hall at the University of Ottawa, or was at the point when it was taken. It still is outside there, but it's not all parking lot anymore. So we see here that if we just zoom into that little part of the image, we see 1 car, 2 car, 3 car, 4 car. So we see 4 cars there in that little section of the image, and they're easily distinguishable as likely cars. And we can see that they are different cars in that the background here, which is kind of a greenish area down here, is evident between each of the car parts of that image. So the pixels that represent the cars are darker or lighter than the background, and so we can distinguish them that way. So if our analysis required us to count cars within a parking lot, a half-meter resolution would be sufficient for that, because we could then count the individual cars. Of course, that's a simple example, but it's a good one. At 4-meter resolution, we can probably surmise, or just by looking at this area again with our eyes, that that's parking lot and that's building. And this is lawn in Taberry Hall and trees. Pretty easy to see. But counting those cars becomes impossible at a 4-meter resolution. Zooming into the same location as we did over here on the left-hand side, we can no longer see individual cars. At a 10-meter resolution, we can't reliably distinguish even between what is a building and what is a car, what is part of a building and what is part of a car or a parking lot or something. At this resolution, we can kind of see that, well, this is a green area over here. That's probably a building. Just using our own knowledge, I'm not sure what that is. It's probably trees again or something like that, little tree spots here and there, and non-tree spots. So we can have dense, dark vegetation, lighter vegetation, and perhaps pavement in this regions here, and just general built-up area. But we certainly can't look or count cars in a parking lot. At 25-meter resolution, well, we might be able to say we have built-up area, non-built-up area, vegetation or non-vegetation, but that's about it in this case. Certainly, counting cars is out of the question for everything here, but the half-meter resolution. So resolution is fundamentally important when you decide you need to represent something in a raster that's a discrete entity or a continuous entity as well. So generally, by coarsening the resolution, we lose detail. By increasing the resolution to a smaller cell size, we increase detail. So detail of what we can represent, as well as the types of things we can represent, depend on resolution. With the smallest cell size, we can represent more different things in the world that we observe than we can with a larger cell size.